Hello and very welcome to the In My Cloud webinar series Connect X 2019, the Manufacturing Sales Solution. Today's industry talk is on precision engineering and plastic processing sales scenarios. Your hosts today are myself, Michael Butchko, Sales Director for the DACH region based out of Munich, together with my colleague Dr. Falk Brauer, Senior Vice President Global Center of Excellence and Pre-Sales, and Alexander Peukert, Vice President Cloud Consulting. We are thrilled to share with you how our customers could, can, and will in the future also continue to digitalize their sales process with our standard sales platform that is fully dedicated to the manufacturing industry. By bringing processes, people, collaboration, as well as pricing, quoting, and order generation into our system, a fully digitalized sales process becomes a reality. On one hand, it makes management enjoy profitability and better forecast visibility, as well on the other side, employees to follow a standard and solid sales process together with their collaboration with their colleagues. Well, in the digital era that we're living in today, expectations and experience in digital working and consumption show and make us actually feel a big gap. In personal life, online or let's say digital consumption is easy and comfortable, no matter whether I would like to buy a product or services. However, in business, it looks a bit different. Talking then about manufacturing, it looks even harder. My experience in a manufacturer's sales life for a product and contract manufacturer showed even more challenges. So, what are the challenges in that industry? Further on, in our today's webinar, we're looking into contract and precision engineering and what is done today for cost calculation for projects and mass production. We give you a short insight, of course, about us, what we mean to cater your customer and your company into a satisfactory and winning customer journey, what are the challenges a little bit more in detail and how can those be converted into a seamless sales process catered by one system, and then show you a real end-to-end sales processes in our software. So, Alex, please let us know a little bit more about the challenges and the differentiators that we face in that industry.
Thanks, Michael, for the great introduction. So let us take a look at the top challenges in the manufacturing industry. First of all, we see the market volatility. This means, from customer side, there's always a changing demand. That especially affects the production forecast and in the end the production costs with the production efficiency. If the lot size, for example, is getting smaller, then the fixed cost, like setup costs or tooling costs, need to be absorbed by lesser parts, which is increasing the part price again. The next thing we see is the rise in labor costs and also material costs. Previously, countries where you could manufacture on low costs are having a rise in the wages. Also, the material costs, especially for the raw material, are changing frequently. One reason for this are, for example, new introduced import taxes. Managing the labor and material cost change in especially long-running contracts, which can be 3 to 5 years, is consequently a big challenge in the manufacturing industry. On top of this, we see the price pressure. The customers are constantly asking for a reduced price, which is against the trend of the rising labor and material cost. Especially in the contract manufacturing industry, the contractors are asking for yearly price reductions in the long-running contracts. The last big challenge is the global competition, which again is coming back to the price pressure which is getting applied. So let us now take a look at the top differentiators in order to face the challenges just mentioned. First of all, there are the production capabilities. Which processes can I use in order to manufacture a product? How do I ensure the quality so that the customer in the end is satisfied? Also managing a global supply chain here with intercompany business and multiple plants. Another differentiator is the speed of decision making. This is referring to the first inquiry of the customer, which should be answered fast, as often the first one is winning the project. However, this is also referring to changes in the demand and changes in the requirements during the production process. Overall cost structure is referring to controlling the costs tightly. This means focus on the core competencies and also outsource other processes and sourcing smartly on a global scale. Last but not least, the differentiator is also the innovation. This is referring to the process innovation by continuously enhancing the production processes. But it is also referring to Industry 4.0 and the digitalization, which we especially also have inside the quotation process. So what are the strategies that companies in the manufacturing industry can apply? Every company wants to be in the upper right corner of the matrix that we see. So having high profitability and high revenue growth. If you're able to do that, then your focus is economy of scale. You should always identify the best opportunities and go after them, strengthen your go-to-market channels, and also see that internally you optimize your process. If you have a high revenue growth, but your profitability is rather small, then see that you expand your portfolio, that you're scaling your sales force, and you grow into the go-to-market channels. Now let us take a look at the upper left corner. This is also where I see most of the contract manufacturing companies. Over here, when your revenue growth is rather small, but your profitability is fine, then you need to make sure that you focus on it. This means you should minimize the cost, standardize as much as possible in your operations process, but also in the sales process, and maintain highest efficiency as possible. So all in all, you constantly need to control and monitor your margin. This is also what I'm going to talk about later on, and when we see Falk, when he's talking about the different cost components and how they play together in order to achieve good margin control. So let us now take a look at one of our customers. He's from the precision engineering in the automotive industry as a contract manufacturing supplier. That qualifies in the matrix that we saw on the previous slide to the upper left quadrant with focus on profitability. So how can they focus on the profitability? That first of all means controlling the costs. For this, they need a unified costing system for specialized products. The system should implement the global costing and also pricing methodology, which is controlled centrally by the headquarters. Previously, the plants were working independently. Doing the costing now in one unified system is improving the collaboration and the benchmarking between the plants. Also, the lead times for the inquiry processing is improving. Global cost and margin control is crucial. The sales process needs to be streamlined, ensuring that we always capture the right cost and in the end provide a good and competitive price, which is agreed by finance and all the other business operations. Mistakes over here can be disastrous. On the other hand, also there are lots of opportunities that you can get by implementing such a system, especially when it comes to analytics and comparing what have you quoted versus in the end what are the actual production costs. Another key part in the quotation process is the transparency across department and also across the locations. So having all master data in one system, we can simulate which plant is the best plant in order to produce for the job and where can we maximize our utilization and where can we in the end maximize and ensure the profitability. So those deepened financial insights into the quotation, which are delivered via the analytics capabilities, ensure that in the end the profitability targets are hit, and also we are reducing the risk for the midterm and also long-term cost structure projections through the simulation capabilities. Which means all in all, the business decisions are better, faster, and also more informed from the management. And everything is in the end backed on data. So let us take a look at the status quo on how the cost estimation is still done in a manual way for a lot of companies. Normally, we see spreadsheets like you see over here. A lot of quite complex spreadsheets with a lot of formulas, with VLOOKUPs, with master data, all inside one Excel sheet. So it's very difficult to collaborate on this sheet together. Maybe it's on a file share, but maybe it's also just sent around via email. The next challenge is to update your labor cost and also your machine cost structure when you have a financial year close and you need to update it. This is quite tough when it's distributed amongst multiple Excel sheets and not controlled via one central place. But what are the inputs in the end on the sheets? So you need to make sure that you capture all the costs, which is starting from the material costs, the labor costs, and then in the end also the indirect costs, financial costs on top, and we want to have a price and a profit, of course. But what happens if we need additional equipment? This could be tooling, for example, in order to mass produce a certain part efficiently. Or it could be even a new machine or a new production line that needs to be set up exactly for that job. So there we need to take a decision whether this is amortized on the piece part price or paid directly from the customer. Well, when we do the costing for mass production, the most important parameter are the quantities. So the monthly order quantities, which are also our production quantities. This is affecting especially all the fixed costs, which are then shared amongst the parts. So the examples here are especially setup, the maintenance, but also the tooling costs. This brings us again to one of the challenges that I mentioned earlier, meaning the volatility and the change in demand. When we take a look at the mass production, then normally it starts first with a prototype, then with the first series, and only then we reach the mass production phase. And even in that one, we will have the production ramp up, where the number of parts is in the beginning smaller, but is getting bigger over time. So what we need is we need to simulate what is the price for the different order quantities for which point in time. For this, it helps if we have a system and we can do simulation in different runs, what you see on the screen over here.
Hey, thanks Alex, but not so fast. Let me quickly introduce our company really briefly to our audience. We at InMind Cloud are there to help you fulfilling your sales process digitalization and provide your company and your customer an optimal customer journey so that you can win more business, increase profitability, and become more transparent. We're all dedicated in being the leader in sales process automation for the manufacturing industry. So our individual and company experience in manufacturing allowed us to have productized the engineering or manufacturing sales process into a standard sales platform that we actually call the Manufacturing X Sales Platform. As an independent software vendor, we closely cooperate with SAP in order to bring a deep integration into your back-end systems. For special needs, we have technology partnerships. It allows us to check which technology we want and we need to use in order to improve our standard sales platform and thus our customer sales processes. And to provide you the best possible service, we cooperate with a global partner network. And as a rapidly growing cloud software provider, we are present around the globe. Likewise, we have a global customer base. Based on our industry talk today, with focus on the manufacturing, sub-vertical contract manufacturing and process engineering, our customers Interplex and Heiko are running the MX platform in their business and are therefore a good example. We serve many different subsegments inside manufacturing, despite all those face different challenges and business processes. All those industry examples seen here on that chart actually have one thing in common. All are using the same standard manufacturing sales platform. Before I'm going to hand over to the Center of Excellence lead Falk, let us look at a realistic customer journey with manufacturers in general. Unlike in personal life, where an easy customer journey allows spending the hard-earned money very easily and very quickly, the requirements and needs in manufacturing are not as simple as the shopping experience in mentioned personal life. As your potential customer, I will reach out to different vendors to get competitive offers for my needs. Vendor A could not provide me an offer in time at all. Vendor C, not capable in fulfilling my requirements entirely. Vendor B, hopefully you, though offers the competitive offer I need at the right time with a promised production schedule so that I can use the ordered components, parts or good in my manufacturing process without any hassle and on time. And if I identify during my manufacturing process that I have additional needs and you can cater for that additional business easily, I will be even more happy as your customer. So what we just saw in that example, if you can give your customer an optimal customer journey, it will not only speed up your process in the sales, your visibility for the company, or having a very transparent view on what you're actually currently offering, but it also allows to have a high retention rate of your customers. In last month's webinar about mechanical engineering, we were talking in detail about the journey, the different perspectives at the various stages during the sales process or the customer journey, as well as the configuration of products. Today, however, we focus not on the standard products or solutions, which are, let's say, easier configurable because they have underlying product models, but today we are more talking about the costing and pricing, which is much more complex since you don't have a fixed product model. You're trying to engineer something which is maybe not even existing or partially existing. So here it gets more complex because various departments are involved: engineering, PM, supply chain, tooling, engineers, and so on. So I'm excited to hear from you now, Falk. What does it mean for our customers in detail?
Before we look into the manufacturing X solution, let's talk about engineer to order in different business models. The first class of companies work with standard products. Examples are industrial machinery, mechanical engineering, or medical technologies. They sell standardized products but still allow for special manufacturing requests or locally purchased components. Their business model is usually direct or inside sales. So they sell high-value products with low to mid-range volumes and, as mentioned before, allow minor adjustments. The special adjustments could be color, special drillings for assembling the solution, additional features, or locally purchased components like printers or the like. The next type of business model is centered around projects. A project in these companies usually is built around standardized components that are used to assemble engineered solutions. Examples are in mechanical engineering, electrical engineering, plant engineering, or precision engineering. The business model could be centered around one-off projects, selling solutions rather than products, directly or via distributor. Usually the projects are of high value with medium or low value components, such as pipes or the like. Examples are, for instance, telco solutions, which are built of communication equipment, electrical solutions, such as switchboards, or businesses which are focused on maintaining industrial equipment, such as turbines of power plants. A special class of business model, which we will focus today, are custom products. So really products which are meant for mass production. Examples can be found in industries such as automotive suppliers, aerospace, precision engineering, or contract manufacturing. The business model is usually direct, high volume, low to mid-value products, and long-running contracts. We dominantly see this kind of business models for metal and plastic products and automotive components. While the business models that we just discussed are very different, they have also commonalities, but also they have differences. Let me walk you through the most important steps in the sales process and explain where the engineer to order kicks in. First of all, let's look at the company that is selling standard products and how the optimal journey through the sales process for a customer looks like. First of all, there's a phase of raising awareness. I, as a customer, exchange contact details with a salesperson in charge, and the CRM system should allow the salesperson to keep in touch with me. Next, once my need as a customer is specified, I expect an accurate solution configuration. Also, I might have some special request, let it be the color, a special engine to be used, a special capability that I need. And the salesperson needs to collaborate with his engineering team to calculate the cost for those. Once the price is negotiated, I expect a detailed proposal which gives me all the details that I need on the solution that I want to buy. On this way, the salesperson working in CRM had a lot of touch points with backend systems such as ERP. For instance, the configuration of the solution might be stored in there, or the prices might be calculated with an ERP pricing engine. Also, the costs for special requests are not random. Usually they rely on rates or components that are available in a backend manufacturing system. So even for engineer to order, a backend system connected to the CRM system is highly important. So once my quotation turns into an order, all the information that was generated during the sales process so far needs to be captured in the backend manufacturing system. That means at least that a sales order is generated in the backend system, and for engineer to order, a new product, material or item needs to be created in the ERP too. This includes the production plan as well as the production bill of material, which is very important for accurate manufacturing. Ensuring a smooth integration between CRM and ERP makes sure that you get the right solution at the right time, at the right place, for the right price. Of course, the business relation doesn't end with one purchase. For a machine or some other good, you will need additional services, spare parts, accessories, and the like. And for me as a customer, it should be very easy to purchase those items in a self-service fashion. Nowadays, nobody is interested in filling complicated order forms or talking to inside sales via phone to explain something which could be done in a few clicks via a customer portal. So how does the optimal customer journey in a project business differ from a product business? The beginning is very much the same. You work with your accounts and contacts, you generate leads for projects, but once you're in an opportunity phase, a lot of things changes. You start working on a project structure, and the project structure is determined by your capabilities. Then comes the cost calculation. The cost calculation depends on raw materials, components and their costs, activities and machines that you own, and the rates that you maintain for it. Those may include direct costs but also indirect costs, which you capture usually in your ERP. Once you determine the correct costs, your pricing is based on markups, and you start negotiating based on that. The proposal generation is the final step to create a quote, and once you agree with your customer, you're ready for project execution. In the age of Industry 4.0, you don't want to rely on Excel sheets or the like to execute your project. Usually you want to leverage your ERP capabilities and keep the manufacturing steps and the bill of material required for project execution in ERP. So in the simplest case, you could create a new material together with a routing in ERP, defining the steps that are required, the estimates and the components to be used. For more complex projects, where you need detailed monitoring, you might look at more complicated solutions such as SAP project systems to keep track of your bill of material and routing and the resources required and consumed. All this needs to be seamless so that nothing is lost from the quotation stage and all the information is available in your ERP system for the actual manufacturing stuff. So at the end, you are able to execute your project on time and on budget, and you can look forward to repeated service orders for similar or other projects. Before going into more details on the mass production scenario, let's have a short look into a demonstration on how we quickly can quote a project and create all the necessary data in ERP for the manufacturing execution. When I enter the solution, you will see first your work list, your current open quotes and opportunity. Of course, there's also some dashboard capabilities. In Manufacturing X, you have your accounts, opportunities with a pipeline view, of course, and quotes. So we don't spend now much time on the CRM features. We just create a quote for a new turbine maintenance project. So within the project I have now many options, so I could copy from a previous quotation a structure, or I could build it from scratch. Let's do that. So I take the project as a header item, and from the project I can now build the structure. So that's a very simple type of modeling. So I can simply select, for instance, first the work centers, which are machines and activities, and I can select the raw material that is needed, which is a certain powder for the spray activity. So now I have a basic project structure here, and what I can see is here the unit of measure for the activities. They are measured in hours. Of course, I could have also a more complicated model that calculates me the hours required. So for now, I simply go with, say, 3 hours of grid blasting, 4 hours of labor for spraying, which includes the setup and cleanup afterwards. And for the machine, I will use 3 hours, and the material that I estimate for this job is like 35 kilograms of powder. So here I see the markup column, so I could mark up the whole project, let's say by 20%. And maybe for the powder, I only take 10%. So in the next column, I see my costs per unit. So 1 hour of labor for spraying would be, for instance, 380 USD. My total cost 1,520, and my total price 1,824. So as I said, that's a very basic example how you can combine activities and raw material into a project. And now comes the even more interesting part. I want to create an order in here SAP ERP. So, and the trick here is that we will first create a new item, a new project with all its master data. So it's really a real material in ERP, and I can simply create this with one click. So that's more a guided process. Next I create the bill of material with the powder, and next I create the routing, which are actually all the work centers, the machines, and labor activities. The last step is creating a sales order, which I can simply do like this, create. So now let's see what all we created in ERP. So let's open ERP for this. In this case, as I said, SAP ERP. So the first thing we will have a look at is the material that was created. So, and we see all the master data is available in the ERP. So we now will have a look at the bill of material, which is transaction CS03 for the same material, plant 1000. And we see here our powder. And next we will look at the routing, so the manufacturing process. For this material, and see we have 2 work centers assigned, which have machine hours and labor hours. Last, let's check the order and the production plan in the order. So for this we go into VA03. So this is our order. We see it has a one-line item, which is the project. We can also see the price of the project in here. We can look at the schedule line and see the production order as well. In the component overview, we see again our bill of material. And in the operation overview, we see our 2 work centers. So that was a little demonstration of a very simple project where we directly enter the required work and machine times. Of course, as I said, this could be more complicated and more guided with the help of a configuration which helps to find the right operations and calculates the correct times. Last, let's have a look on the customer journey for mass production. While the flow looks very similar, the processes behind are very different. Once an opportunity is identified, the engineering and design team analyzes the requirements and drawings that it got from the customer. Based on that, design and potential production process is proposed. With this, cost model and calculation phase starts. This is spread across different teams. Purchasing, production, finance, and so on need to work together to produce a precise simulation of the costs that occur during production. This includes also indirect costs as well as consumables like tools and other things that need to be amortized across the different parts. Also, loss during the production is an important factor. Another critical part are minimum order quantities per month. Those will determine also the setup times required, for instance, because you could have a dedicated production line, or you could run on one production line multiple of your projects. The cost estimation for mass production needs to be extremely precise, since the margins are very thin and the parts are usually of lower value. Once the costing is completed, the price determination starts. This is based on margins, which are usually quite low and are also part of the negotiation. Often during negotiation, you also will need to disclose your cost structure, which is part of the proposal generation. In difference to previous processes, the result is not an order. It's actually a contract that determines the cost structure and prices that you agree on, and clauses that determine the rules for price renegotiations. Multi-year contracts usually also include clauses where the parties agree on an annual price reduction by a certain percentage based on productivity improvements. Often, especially in the automotive industry, with the initial contract closure, the actual design will be worked out in detail. So there might be changes to the overall cost structure and agreements. Once the product is ready for mass production, the production plan and bill of material needs to be maintained in ERP. As we have seen before, that's possible with Manufacturing X. So no additional manual work, which might be caused to error, is required. Mass production then usually starts with a pre-serial production and then later turns into mass production. Still, there might be engineering changes and other details that are changing during mass production. For instance, it is not unusual to negotiate on 20 to 30 price changes in parallel in automotive. This process also needs to be supported by a CRM system. Instead of proposing total prices, price changes are quoted. And the final result is not an order, but a price change in ERP, so that the mass production can run. And of course, to support such price renegotiations, the CRM system also needs to keep track on the costs that were calculated and agreed initially. So let's see where there are potential obstacles in running such a costing process. Here you see a process flow that we usually see in costing mass production products. First step is you receive a CAD drawing and product specification, and you need to work out your manufacturing plan. This data is crucial and needs to be archived together with your costing data. Next step is the costing, which is often based on Excel. So huge Excels are created and sent via email or put on file shares. This is a very critical part of your business, and you need to be very cautious with that data. Better keep it in a dedicated system where it's archived over time. Next comes the cost calculations, which is often also done in Excel sheets. You need to reflect all your dependencies in your costing and your production process. Doing this in Excel is very dangerous at times. Last comes the customer cost breakdown if required. This is a very crucial document for later reuse, especially during price negotiations. Once the mass production starts, all the production plans and bill of materials needs to be kept in ERP. Transferring this manually might be error-prone at times. With start of the mass production, your negotiation doesn't stop. There might be any kind of commercial changes that are agreed upfront, or that come from currency exchange rates or anything like that. Productivity might increase and you might lower your prices. There might be cost changes in your raw materials or purchased items, which you need to pass on to your customer. And of course, your customer might inquire for engineering changes, or you might propose them to save costs. Running those processes in a centralized CRM for manufacturing really helps to decrease labor costs and reduce a lot of errors with more precise results. Let's jump back into our demo system and have a look on a still simplified example of a costing model for mass production. While previous demo was very technical, we will now go through a complete customer journey and start with a portal-like approach, then see how costing and mass simulation works, and at the end create a product and see how the customer might work with those for after-sales processes. As mentioned before, we start with a customer portal approach, where the customer can browse products that are produced for him, or create new inquiries and upload his product specification. In this setting, Manufacturing X can be embedded in your website and can open with a guided selling, which allows to see your product portfolio. This guided selling works like a questionnaire, and you can navigate different categories of products, which also helps to demonstrate the portfolio of products that you produced in the past. Let's now create a new inquiry for a mass production product. We can simply go to attachment and upload the specifications. Which includes PDF, drawings, pictures and the like. Next, we can route this inquiry to a sales representative who will further handle the process of cost and price negotiation. This kind of portal approach is great to directly exchange with the customer based on the specification and cost breakdown details. Of course, the customer can only see what he should. Now the sales representative got an email. He can log into the system and see the inquiry in his inbox. In this case, he is reminded of a previous quotation that he did in the past, which was very similar, and he hopes that the engineering can reuse this data to create this new mass production cost breakdown. In this example, the mass production is about interior trim for a Volkswagen Passat, which consists of 4 different plastic parts: the main interior trim, loudspeaker cover, and few decoration elements. Let's jump into the costing model. In the costing model, you can set essential input parameters such as the plant, the minimum order quantity, the machine to be used for the molding, the cavity, which is the number of items produced in one cycle, and the cycle times, as well as efficiency and loss. Based on those input, rates and prices are loaded from the internal database, which might be synchronized with your ERP system, to have always the latest costs available. Based on information from engineering that worked on the planning of this part, it got known that the production cycle time will be a little bit different to the previous order, and that the raw material requirement is slightly different. Also, the material to be used should change. Further, we see tooling costs, which are very similar to the old quotation. Since we also need a right door, we copy the left door and do final adjustments. The raw material requirement will be slightly different. Next, we can see a cost breakdown that is aggregated to material, labor, and so on. To simulate certain alternatives, we jump into the mass simulation mode. Here we see all the processes and can do a mass configuration of them. So now we can generate different versions of our costing model so that we can quick and easy compare the different options. Here we show an example where we analyze the behavior of the efficiency factor on the total costs. Then we can run the simulation, and the system will do an end-to-end cost calculation with the alternative parameters. Here we now can see the total costs and prices, including the breakdown. Last, we can choose one of the options to be the one that we want to send to the customer. Also, we could see if we assigned tasks to our departments, whether they are finished or not. As a final step, we create a material similar as before, after, of course, the customer agreed. And we can release this to the product catalog so that it's available to the customer for any further process. Also, this enables us to do price and cost tracking in the future. For instance, if there's an engineering change or some other changes. The customer also can see the newly produced parts in his portfolio. This was a very brief demo on costing in Manufacturing X. We didn't spend much time on the details of the costing itself and the mechanisms that are usually used. So we would like to do this on a schematic example. Here is a schematic overview of an example cost calculation for a plug which consists out of steel, gold plating and resin plastic. On the left hand side you see core assumptions. So you start usually with an assumption on the monthly quantity and the duration of the production. Of course, these are parameters which could change during discussions. Based on your production capabilities and the monthly quantities, you can come up with an assumption on your machine usage and your production lines. Based on this, you can decide whether you either run a dedicated production line or whether you run the production at certain points in a month. In this example, we assume that the production line is set up every month to run the production. Second consideration is tooling. So for the molding and for stamping processes, you need special tooling which is not cheap either and could be either paid by the customer directly or will be amortized with the part prices. Next, there's a piece of engineering and design. Again, this can be paid directly or amortized. In some cases, you might use reusable packaging to transport the goods from A to B between the plants. These are also costs that you need to consider. Last, you might need to buy additional machines which are dedicated for this production and again can either be paid directly or amortized over the part prices. On the right of the schema you see the final cost summary and in the middle the calculation flow. You see within the calculation first of all the raw materials, gold, steel and resin. Second, you see the processes or work centers, which are stamping, plating, molding, assembly via auto assembly line, QA testing, and then the final product where your markups apply. The blocks within the process chain depict different cost factors that accumulate across the value chain. Most important are raw materials, labor, process costs, amortization, and at the end overhead and profit. In parallel to the value creation, there's also loss. While the value creation moves forward, the loss is accumulated at the end. So the more loss you have in a later production process, the higher will be your material costs. So they need to be aggregated at the end. Also processes create loss. Those will be mapped to the production process costs and are therefore marked in green. With every step of your production, from the raw material, for instance steel, to a process, value is created. and the value is recorded in costs and accumulated across your process chain. At the end, your accumulated costs reflect the value that was generated during your production process. The last step is to add additional overhead, the investments, packaging and engineering costs are broken down via the total quantity of this production, which is 10 million. As a result, you retrieve a breakdown into different cost categories, such as raw material, labor cost, process cost, amortization, overhead, and at the end we add the profit. So for this example, production process, we would receive a final part price of 4 cents, which includes all the costs that are generated through the process, including amortization for investments, packaging and engineering, overhead, and some profit added on top.
Thanks, gentlemen, for that very interesting demo and walkthrough to the market. But what actually my customers care is about? What does it improve in real value? Features, functions, all is nice. The software is obviously really great. But what does it really in the end bring you? So today in globalized markets with tough competition, different advantages of locations make the pressure raise and raise. On the other hand, also the customer has higher and higher demands and expectations, not solely towards the seller's process or deliveries of goods, but also towards the product and innovations of it. Despite long sales cycles, the customer experience can be great and profitable for the manufacturer. So how does it look like for some of our contract manufacturing customers? Since the manufacturing CRM contains all information data that is required for the entire sales data, as well as an integrated costing and pricing of manufacturing offerings, as well as the capability to flexibly jump forward and backward during the entire sales process, our customer base could increase the revenue by around 5%. At the same time, by optimization of processes, streamlining, data consistency, modeling, profitability increases of approximately 15%. Interesting is the conversion rate increase. Due to the collaboration between sales and the other teams, the modeling of the processes, it has led to massive improvement of the speed and engagement with their customers. So that is actually resulting in a 30% increase of conversions. In my previous manufacturing life, one thing that I have always tried to conquer were the lead times of 12 weeks. Our in-mind cloud customers have shown that with MX Sales Platform, it is possible to reduce the lead time by 60% in average and not in the best cases. So that is obviously a huge market advantage. Thank you very much for your interest, dear audience. Please share your questions with us, or you may also contact us at any time after the webinar as well, using the email addresses or of course also the contact information that you already may have present. Thank you very much.